Okay, let's graph a nonlinear equation, y equals x squared minus 1. We're going to use a t-chart just like before. And we'll plug in some convenient values of x, maybe 0 in the middle, and then -1, -2, and how about 1 and 2? Those would be nice values. Okay, if you make -2 the input, in other words, the x value that you're plugging in, then you're going to get y equals -2 squared minus 1, which is the same as, okay, you have to square out the negative as well as the 2, so it's 4 minus 1, which is 3. And then if you make the input -1, it's going to be -1 squared minus 1. -1 squared is +1, so you're going to get 1 minus 1, or 0. If you plug in 0, I'll bet we don't need to show a whole lot of work. What happens if you plug in 0 right here and square it? You get 0. Minus 1 is -1. If you plug in 1, heck, you're going to get the same thing as if you plugged in -1, because the negative squared out when we plugged in -1. So -1 squared is the same as 1 squared, so you're going to get 1 minus 1 again, which is 0. Same thing with this guy. If you plug in 2, it's the same as plugging in -2, because the negative gets squared out, and you'll end up with 3. So we plot these values. I'm going to start with 0, -1, and then 1, 0, -1, 0, -2, 3, and 2, 3. And then connect the dots. Use a nice smooth curve. It's not a V shape at the bottom. It's a nice rounded shape at the bottom. If you don't quite make it through your point, just make the point bigger. As long as you're not too far away from it, that works. And then arrows on the end to indicate that this graph keeps going up, and also it keeps getting wider and wider as you go further away from the y-axis, which would be this vertical axis right here, x and y. That's it. That's your review of how to graph. In this case, it's called a quadratic function. You don't need to know that yet. Just realize it's not a line, so it's a nonlinear. I called it a function. You don't even need to call it that yet. You can just call it a nonlinear equation. Okay, your second example of a nonlinear graph is going to be y equals absolute value of x minus 1. Not all that much different from the last one, except instead of having an x squared right here, we have absolute value of x. So same idea. Let's plot some points. X, y. And we're going to plug in 0. Same values as before, I think will work. -1, -2, 1 and 2. Don't get the wrong idea. You don't always use these input values. Sometimes there are more convenient values to use, as you've seen in other examples. But for this example, it'll be nice. So, okay, what happens if we plug in -2 for x? We get y equals the absolute value of -2 minus 1. Now, remember what absolute value symbols do. They, when you plug a number into absolute value symbols, you're just measuring how far that number is from 0, regardless of the sign of the number. So the absolute value of -2 is just +2. And so you get 2 minus 1, which is, of course, 1. So an input of -2 goes to an output of 1. What happens when we plug in 1 for x? We get, or -1, how about? We get the absolute value of -1 minus 1. Of course, the absolute value of -1 is +1. So you get 1 minus 1, which is 0. If you plug in 0 for x, then this whole thing goes away. The absolute value of 0 is 0. And you get -1. For your output, input 0, output -1. If you plug in 1, the absolute value of 1 is 1 minus 1, and that's going to be 0 again. In other words, you're going to get the same thing you got when you plugged in -1. You're going to get 0 popping out. Likewise with 2, since the absolute value of -2 is the same as the absolute value of 2, you're just going to get 2 minus 1 when you plug in 2, and that's going to turn out to be 1 once again. So we plot these values. I'll start out at 0, -1, and then we're at -1, 0, +1, 0. So I'm not plotting these in order. I plotted this one and then this one. And then -2, left -2, up 1. That's this guy. And then right 2, up 1. That's this guy. Now this graph will, unlike the last example, this graph will be a V shape. So it'll be like two lines stuck together. Let me try that again. Try and make it through the points if I can. Two lines stuck together. It's a harsh angle here at the bottom, a sharp angle here at the bottom. It really is a V shape. Unlike the shape in the last example, which was a parabola. It was a kind of a rounded shape at the bottom. This is a V shape. And anytime you get y equals the absolute value of x to like the first power, you're going to get a V-shaped graph, or an upside down V-shaped graph if there's a negative out in front. Anyway, there you go. That's the graph of y equals the absolute value of x minus 1. So these are supposed to be arrows in the end. Remember what the arrows indicate? They indicate that the graph keeps going not only up, but keeps getting wider and wider and wider. So that's the graph of the absolute value, y equals the absolute value of x minus 1.